As many of you know, microcontrollers are fundamental in embedded systems. For some applications, ultra-low power devices are required, but these devices have some limitations. Many low-power microcontrollers do not have a floating point unit. This unit is a coprocessor that performs mathematical operations involving floating point numbers. The FPUs consume a lot of energy because they are designed to be extremely fast and efficient at handling complex calculations, so they use a large amount of electrical power to perform these operations in a short period of time. Without FPUs, it's impossible to calculate operations or functions that require decimals. There are libraries as math.h optimized for these devices that allows calculations with decimals. But they could be heavy for low-end MCUs, and sometimes they take a lot of resources to operate with these libraries, affecting the energy consumption. An ultra-low power microcontroller is a device designed to minimize energy consumption, making it ideal for applications that do not require high hardware capabilities. These microcontrollers typically incorporate efficient processors, which offers good balance between performance and energy consumption. This type of microcontroller is commonly used in portable devices, wireless sensor, medical devices, and automation systems. To maximize battery life, these systems implement sleep or standby modes, energy management techniques, hardware optimizations, and efficient software usage. Today, energy consumption in standby modes has reached levels as low as sub-microwatts. To solve these problems, we can use CORDIC. CORDIC is an algorithm proposed by Jackie Boulder in 1959 for the calculation of trigonometric functions, multiplications, and divisions. Nowadays, the use of CORDIC has expanded to many mathematical operations such as logarithms, exponentials, and square roots. The CORDIC advantage is its efficiency, allowing its operations to be done using addition, subtractions, and bit shifts. These operators are considered low-cost in programming due to their minimal computational requirements. CORDIC has two implementation modes, the rotational mode and the vectoring mode. In the rotational mode, the required rotation angle is provided as an input, and the final components of the rotation are obtained as output. In the vectoring mode, the inputs are the coordinates of the vector, and the output is the amount of rotation needed to make the angle 0. This project focuses on the rotation mode. The disadvantage of CORDIC is that the operations made by the algorithm are approximations, so there will always be an error which magnitude depends on the number of iterations made. This error is due to the fact that real rotations are not performed. The algorithm performs pseudo-rotations where the vector components move by a fraction of the previous iteration's vector length. For the project, I will use the MSP430 FR2355. The MSP430 family from Texas Instruments has an architecture focused on power consumption and efficiency. Its peripherals are activated only when needed, featuring a flexible clock system and advanced power management technologies. In these microcontrollers, hardware modifications have been implemented to prevent current leakage, along with software library adjustments and new architectures for energy management.